Global warming refers to the long-term rise in Earth's average surface temperature due to human activities, specifically the emission of greenhouse gases like carbon dioxide, methane, and nitrous oxide. While the Earth's climate has naturally fluctuated throughout its history, the rapid warming observed over the past century is primarily attributed to industrialization, deforestation, and the burning of fossil fuels. This warming is having significant environmental, societal, and economic impacts across the globe. So in this video, we are discussing the how fast is the Earth warming. So before we start, please like this video and subscribe to our channel for future updates. According to NASA, the average global temperature has increased by approximately 1.2 degrees Celsius since the late 19th century, with the most noticeable and alarming rise occurring in the last few decades. In recent years, the pace of warming has become a key concern for climate scientists, policymakers, and citizens worldwide. Understanding how fast the Earth is warming, what is driving this rapid increase in temperatures, and the potential consequences of this change are vital for shaping effective responses to the global climate crisis. By examining temperature trends, the causes of warming, and projected future impacts, we can better grasp the urgency of addressing climate change. The pace of warming, decades of change. The Earth's temperature has fluctuated throughout history, with periods of warming and cooling that occurred naturally. However, the recent warming trend, which has been observed since the late 19th century, is occurring at an unprecedented rate. The most significant warming has been observed in the last few decades, particularly since the 1970s. According to the National Aeronautics and Space Administration, NASA, the global average temperature has increased at a rate of about 0.2 degrees Celsius per decade since the 1970s. This is a significant acceleration compared to the natural variability in Earth's climate in previous centuries. The last 5 years, 2019 to 2023, were the hottest years ever recorded in human history. In 2023 alone, the global temperature was approximately 1.2 degrees Celsius higher than pre-industrial levels, according to the World Meteorological Organization. The average rate of warming over the last century, since 1880, has been around 0.8 degrees Celsius, but this acceleration is a direct result of increased greenhouse gas emissions. As the planet warms, more extreme weather events, such as heat waves, storms, and heavy rainfall, are becoming more frequent, contributing to devastating social, environmental, and economic consequences. A record-breaking decade. The hottest years on record. The 2010s was the warmest decade on record, surpassing all previous decades in terms of average global temperature. The intensity of this warming became especially evident in 2016, when the planet experienced an anomaly in temperatures due to a combination of a strong El Niño event and the ongoing effects of human-induced climate change. That year, global temperatures surpassed the 1 degree Celsius threshold above pre-industrial levels for the first time in recorded history, signaling a major shift in Earth's climate system. In addition to 2016, other years, including 2019, 2020, and 2021, also broke temperature records, with 2020 being tied with 2016 as the warmest year on record. The heat is not only global, but is impacting regions differently. While the overall Earth temperature has risen by 1.2 degrees Celsius, some areas have warmed at a much faster rate. This has serious implications for ecosystems, sea levels, and human societies. Understanding the speed of global warming is critical because it helps us forecast future risks, such as rising sea levels and the growing frequency of extreme weather events. Regional variability. Some areas are warming faster. While the planet as a whole is warming, the rate of temperature increase varies from region to region. One of the most alarming patterns observed in recent years is the phenomenon known as Arctic amplification, where the Arctic region is warming at more than 3 times the global average. According to the National Oceanic and Atmospheric Administration, the Arctic has warmed by about 3 degrees Celsius over the last 30 years, and the effects are particularly visible in the loss of sea ice and the thawing of permafrost. The loss of sea ice in the Arctic contributes to a positive feedback loop known as the ice albedo effect. As sea ice melts, it exposes darker ocean water or land, which absorbs more sunlight and causes further warming. This process accelerates the rate of warming, leading to more dramatic temperature increases in the region. In addition to the Arctic, other regions, such as parts of the Middle East, North Africa, and the Amazon rainforest, are also warming more rapidly than the global average. In regions like the Middle East, temperatures have been rising by more than 0.5 degrees Celsius per decade, leading to more frequent and intense heat waves. Meanwhile, tropical regions like the Amazon have experienced drastic temperature shifts, which have affected biodiversity, forest health, and local weather patterns. The causes of rapid warming: human impact. The speed at which the Earth is warming is directly tied to human activities. The burning of fossil fuels such as coal, oil, and natural gas has led to a significant increase in the concentration of greenhouse gases in the atmosphere. Greenhouse gases trap heat from the sun, creating a warming effect known as the greenhouse effect. While greenhouse gases occur naturally in Earth's atmosphere, human activities, especially industrialization and deforestation, have drastically increased their concentrations since the late 18th century. Carbon dioxide is the most prevalent greenhouse gas, contributing around 75% of global warming. The atmospheric concentration of CO2 has risen by more than 40% since the Industrial Revolution, reaching levels higher than at any point in at least 800,000 years, according to ICE Core data. The increase in CO2 and other greenhouse gases, such as methane and nitrous oxide, is largely due to human activities, including transportation, agriculture, energy production, and deforestation. Deforestation, in particular, plays a crucial role because trees absorb CO2, and their removal not only decreases this carbon sink, but also releases stored CO2 back into the atmosphere. Warming accelerates warming. A critical feature of the Earth's warming process is the presence of feedback loops that amplify the effects of warming. One of the most concerning feedback mechanisms is the loss of Arctic sea ice, as discussed earlier. As the ice melts, less sunlight is reflected back into space and more is absorbed by the ocean, increasing the rate of warming. Another key feedback loop involves permafrost thawing. Permafrost, which contains large amounts of carbon in the form of frozen organic matter, is beginning to thaw as temperatures rise in the Arctic. As it thaws, this carbon is released as methane and CO2, further increasing the concentration of greenhouse gases in the atmosphere and accelerating warming. This cycle could have profound long-term consequences for the planet, as massive amounts of carbon are stored in permafrost in regions like Siberia and Alaska. Projections for the future: how fast will the Earth warm? Looking forward, the speed at which the Earth will continue to warm depends on global efforts to reduce greenhouse gas emissions. According to the Intergovernmental Panel on Climate Change, if global emissions continue at their current rate, the planet is likely to experience a temperature increase of 1.5 degrees Celsius above pre-industrial levels by around 2030. This would trigger more severe climate impacts such as extreme heat waves, droughts, flooding, and widespread biodiversity loss. If we take immediate action to reduce emissions and transition to renewable energy sources, it may be possible to limit the global temperature rise to 1.5 degrees Celsius or 2 degrees Celsius by the end of the century. However, this will require significant global cooperation and investment in clean energy, deforestation prevention, and sustainable agricultural practices. As of now, we are not on track to meet these goals, as emissions continue to rise in many parts of the world. Conclusion: the Earth is warming faster than ever before, and the consequences of this trend are being felt globally. Understanding the pace of warming and its underlying causes is essential for responding to the climate crisis. While we still have the ability to slow down and mitigate some of the effects of climate change, it requires concerted global action. By taking immediate steps to reduce emissions, protect ecosystems, and promote sustainable development, we can work to safeguard the future of the planet for generations to come. So this is our today's video. If you like our video, don't forget to subscribe to our channel or hit the bell icon. We will meet again with another interesting topic. Till then, stay safe and stay happy.